Hey everyone, welcome to this video. Let's talk about fine-tuning large language models or LLMs. So a quick review of the previous video in this course. The base model has next word prediction, which in turn leads to general knowledge, reasoning, classification, and more, but is suboptimal when it comes to following instructions and answering questions, or put more simply, it is suboptimal at being an assistant. The base model has gained enough knowledge from pre-training so that it can be further fine-tuned to become an assistant. So what is fine-tuning? Well, first off, pre-training has the base model gain knowledge, and fine-tuning has the base model train on new data in order to optimize on a specific task. What specific task do we want to optimize for? Let's optimize on the task of following instructions and answering questions. Why this task? Because the resulting assistant model will be more useful and easier for us humans to use. What does this new data to train on look like? It should be discussions between a human and an assistant on a variety of subjects. So maybe we could have the human ask, how long does it take for grass to grow? Or maybe we want the human to ask an inappropriate question and the assistant will refuse to answer it. Like the human asking how to cheat on a test. And the last example could be a human asking a more safe question, like how many days are in a year? And the assistant will say there are 365 days in a year. For creating discussions between a human and an assistant, this data is directly created by humans. People are hired to create the questions and answers for these discussions based on specific labeling instructions. What would these labeling instructions look like? They could be something sensible, right? Like have the answer stay on topic, don't ramble, have the answer be as short and concise as possible. And a really obvious one is do not have the answer encourage doing something illegal or against the law. So we will have labeling instructions that we give to real human beings that we hire, and they will create these discussions between a human and an assistant. Like how long does it take for grass to grow? Or an assistant refusing to answer a inappropriate question from a human, like how to cheat on a test. And then these created discussions is data used for fine-tuning the base model into an assistant. Large language models can also be used for creating discussions between a human and an assistant. A real human being can then review and update the created discussion as needed. Regardless if the discussions between a human and an assistant are created from scratch or with a large language model's assistance, real human beings will always participate in the discussions being created. You can fine-tune a base model with much less training data, created discussions between a human and assistant, compared to the amount of training data, large amounts of unlabeled text, used to create the base model in the first place. Think of this as a high school graduate with 13 years of education, right? Like kindergarten to 12th grade, only needing an additional 4 years of education to be fine-tuned into becoming a teacher. This means fine-tuning a base model into an assistant model is much cheaper and faster compared to the pre-training used to create the base model in the first place. So what happens during fine-tuning training when we turn the base model into an assistant model? Train the base model on the created discussions between a human and an assistant. The base model's weights will be updated to become better at following instructions and answering questions. More precisely, the base model creates text output. Loss then measures the difference for the base model's text output compared to the created discussions between a human and an assistant. and the loss is used to update the base model's weights. Now that was a mouthful. I think this diagram that we have gone over multiple times in this course still explains what happens to a LLM. We have inputs that we pass to the model. The model has weights, which can be thought of as like the knowledge or brain cells of the model. The model uses its weights to generate outputs. We use the error slash loss to tell the model how good or how bad its outputs are. This error slash loss is used to update the weights of the model so that hopefully the model has better weights. If the model has better weights, it has better outputs, which lead to a lower error slash loss used to update the weights to be better again, and the cycle continues. And hopefully, we end up with a model with really good weights, which would mean that this model is really good at following instructions and answering questions. It's really good at being an assistant if we hopefully have really good weights. And now let's talk about the resulting assistant model. After fine-tuning training, we went from a base model that contained a lot of knowledge and was capable of next word prediction to an assistant model that contains a lot of knowledge and that can share its knowledge much more easily by following instructions and answering questions. So this diagram summarizes our understanding of LLMs so far. We use large amounts of unlabeled text like articles, books, text from the internet to pre-train a base model that is really good at next word prediction, which leads to general knowledge, reasoning, classification, etc., and is capable of few-shot prompting, where we use multiple examples to teach the base model how to be a good assistant, like follow instructions and answering questions. But it would be really nice if we did not have to use few-shot prompting to make the base model become a good assistant. So what we do next is we get labeling instructions that we give to real human beings that we hire. These real human beings create data for fine-tuning the base model into an assistant, and this data is discussions between a human and assistant that's used for fine-tuning training to create an assistant model that is much better at following instructions and answering questions compared to the base model. All right, that's it for this video. Thanks for watching.